Now, in the last video, we covered scope and a little bit of pointers. And in this video, I wanted to kind of cover a little bit more in depth about pointers and how they can come back to bite you. In Java and Objective-C and C and C++, inevitably you're going to come up with a situation where the compiler or the system tells you that a variable doesn't exist or hasn't been declared, or any number of different things. And in this video, I'm going to try to explain what is going on when that happens. Now, in the previous video, we had declared a variable up here, and we actually set this pointer to equal I. And that caused the system to go through and actually change the value of I because it was actually pointing at its address. And I showed you how that works. Now, the only thing that I've changed here is instead of setting this to I, I've basically nulled this out. I'm telling it to point to nothing. Now, the question becomes, what is going to happen? And just to kind of trace through this again, what we have here is we have an integer k. Sorry, let me change the size of that. In fact, let me get rid of the great big huge thick line that we just did. So we have an integer k that we're actually working with, and this variable is getting set to the func1, and we're passing j. Well, j is actually a pointer which matches the declaration in the function. I'm supposed to send it a pointer. But the problem is that this line right here is telling the system to dereference that pointer and get the value of that particular variable at that point. So we have a variable that's being declared here, and it's basically a pointer. But when we dereference it, it actually doesn't. It's not pointing at anything. Its value is nothing. So we're going to end up getting a seg fault here because the program, when it runs, is not going to be able to deal with this situation. So just to show you real quick what happens, I am going to jump out here and we're going to compile the code, and you'll notice I didn't get any errors at compile. And the reason is because the compiler is looking for a pointer to be sent into that function, and I'm sending a pointer in. So it's not until runtime that we determine that we actually have a problem here, because the system's going to go out and try to access that memory, and there is no memory. And so what ends up happening is we have this segmentation fault, which is the error that we would typically get in C. The error in some of the other programming languages is going to be a little bit different. So what is happening? Well, let's try to explain what's happening here. So just to go back to our diagram, if we come back in here, I'll make this a little bit smaller than the last one so we don't have to wait for me to draw so many lines. So in this particular situation, we have declared an integer pointer called j, and we've set it to null. Well, what did we actually do? We have our numbering system that we came up with before, just to kind of keep this simple. And so we have a variable, which is a pointer, and we set it equal to an address inside of our memory table. Well, we didn't. We set it to null, which is a 0. So we told it that we don't want it to point to anything at all. Well, then we turn around and we pass that variable into the function, which turns around and calls this function and passes it in here, which so far everything is okay. But as soon as we tell it to dereference this and add it to a 1, well, what ends up happening is it goes in and says, okay, Jay, you're a pointer. We have renamed you to I temporarily, but I want to dereference your value so that I can actually see what you're pointing at. Well, when it tries to do that dereference, there is no address inside this table that points to I, and so we end up with that seg fault. And that is all a result of trying to access that variable when it doesn't actually point to anything. Now, along the same lines, what I'm going to do here is I'm going to clear this, and explain one other situation that comes up that I see people making the mistake on a lot. Is, let's say that I have a unit of code. Let's just call this, even though we haven't really discussed it, let's call this class 1, and in the next video we're going to get into classes. But let's call this class 1, and then over here we're going to have class 2. And let's say that we also have a user interface element that, and we'll just call it UI, that has some fields on it and some text labels and so forth. Now, let's say that in class 1, we go in and we actually create this UI element. So let's say that we have a handle, or I'll tell you what, to keep this simple, let's say we have a global variable and we'll call it G1. That's our global variable, and we set this equal to, let's just say, an integer. So it is going to hold an integer. Right now it doesn't equal anything, it's going to. And so let's say inside of class 1 we come in and we set G1 equal to 3. So, and obviously we would have to, well actually it's a straight integer, so we're okay. So G1 is equal to 3. And so we start accessing this field here and we start working with it. And then over here in class 2, we just use G1. So we say, print G1 or whatever it happens to be. So we're going to print G1. The problem is that it's possible that I create this instance of this class first. So we come in here and create the class 2. So we create class 2. But there is no class 1. Well, class 1 is where we actually are setting the variable for G1 to 3. So in class 2, when we try to access G1, it is a global variable and it is pointing to an int. But right now it's actually, let's just do this. Right now it's pointing to nothing until class 1 sets it. So if I try to access G1 inside of class 2 without initializing that variable, I'm going to end up doing the same thing that we're doing over here. We're going to get a seg fault or some like error message because the system can't get to that particular variable. It knows what it is because it's global, but when we try to access it, the system can't actually get to anything because it hasn't been pointed or it hasn't been initialized to point to anything specific. So when you're working with global variables in multiple classes, and again, I'm going to explain the class stuff in the next video, but if you're working with multiple classes like this, you need to make sure that any variables that you're working with, that they have always been initialized before you actually try to use them. You can usually do that with if statements or other ways of determining whether or not that variable is actually pointing to something. But anytime you get an error like that, and this UI element could be the same thing, where class 1 is actually creating our instance of our UI, but I turn around and try to access that UI from class 2, and class 1 hasn't actually created it yet, so it ends up, I get the same kind of pointer error. Anytime that you try to access a variable that has not been declared or that you don't have scope in to look at that particular moment, you're going to get these types of errors. Now, in a programming environment like Java, where you don't really have pointers, you can still have reference problems like this, where you're trying to reference a variable from one class to another, and because of the order that you're doing things, you don't actually have that variable over there yet to work with. So really, you've got to pay attention to the order. Earlier we were tracking through exactly what order, here's this, and now we call this, and then we come back out of here, and we come back up here. Well, in any programming language, you're going to have that same flow. And you have to be able to kind of think through the exact order that things are being created and things are being done to make sure that at the point that you're trying to access a variable, or at the point you're trying to do something, that variable actually exists in memory and is pointing to something valid before you try to access it. Because if you don't, you're going to get a seg fault in some way, shape, or form.